So this is part 2 of chapter number 2 is matter around us pure. First we will study about the concentration of a solution. It is saturated solution and unsaturated solution. When no more amount of solute can be dissolved in a solution at a given temperature, it is called a saturated solution. So what is it? See, for example, in 50 ml of water, you can add 5 gram of sugar at say 30 degrees Celsius. At this temperature, you can add this much sugar in this amount of water. So if I say to you, add 10 gram of sugar in this water, so will you be able to add? No, you will not be able to add because this is a saturated solution. And if this solution, it is heated, for example, water is heated, then you can add 10 gram, 20 gram, 30 gram, any amount of sugar you can add in the water if this is heated. So we can say that this will become unsaturated solution when it is heated. When more amount of solute can be dissolved in that solution at a given temperature, it is called unsaturated solution. So these were two types. Next is solubility. The amount of solute present in the saturated solution at the given temperature is called its solubility. Now, in 50 gram of water, in 50 ml of water, I can add 5 gram of sugar. So this is the solubility. Next, now what is concentration of a solution? Concentration of a solution is the amount of solute present in given amount of solution. It is same that in 50 ml we can add 5 gram of sugar. So this is the concentration of solution or solubility. Now what is concentration of solution in mathematical form? Amount of solute upon amount of solvent. So this you have to learn, it is very important. The next is two methods of finding concentration of solution. So according to new CBSE syllabus, this second point and third point is cut, only first point is coming. So this I will explain in the next video. Till that you just learn mass by mass percentage is equal to mass of solute upon mass of solution multiply 100. Next is suspension and its properties. So suspension is a heterogeneous mixture. It is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of medium. Example, chalk in water, smoke in the air. For example, now if you take some water in a glass, then I tell you add some chalk powder in it. So you will add some chalk powder, then you will stir it continuously with any spoon. Then after 5-10 minutes you will observe that this solution is not dissolved at all because the chalk powder particles are very large, and this type of solution is called suspension, in which the particles get suspended throughout the bulk of medium, and the solute particles do not dissolve. Instead, when left undisturbed, they settle down at the bottom of container. Now the next is suspension and its properties. Now, first property is it is a mixture. So first is it is a mixture, heterogeneous mixture, and particles are visible by naked eyes because they are very large. Size of particles is larger than 100 nm. So 1 nm is equal to, I have told you in previous video, is equal to 10 raised power minus 9 meter. So it is unstable mixture because the solute particles settle down at the bottom of container over a period of time. If the solution is passed through filter paper, solute and solvent get separated. When we pass this solution through filter paper, the solute and solvent get separated. Like if we pass chalk powder solution through a filter paper, the chalk powder will come on the filter paper and the water will pass through it. So it is a heterogeneous mixture suspension. It scatters light when light is passed through the solution, that is, it shows Tyndall effect. I have told you about Tyndall effect, so it shows Tyndall effect as well. If you haven't seen part 1, so go and see part 1 as well. Next, colloidal solution and its properties. Colloidal solution is also a heterogeneous mixture in which the size of particles is intermediate, means the size of particles is neither big nor small. It lies between solution particles and suspension particle size. Colloidal particles can easily scatter a beam of visible light. This phenomenon is called Tyndall effect. Now, if you take any colloidal solution and if you pass light from one side, then it will come out from the other side as well. This is one of the properties of colloidal solution. Now, properties of colloid. The particles of colloid can't be seen by naked eyes individually. Now, let me tell you first example of a colloid. Example is milk. Now, milk. Colloids seem to be homogeneous, but actually they are heterogeneous. Now, if you take some milk in a glass and tell you to see the particles, will you be able to see the milk particles? No. So we can say that particles of colloid can't be seen through naked eyes individually. It is a heterogeneous mixture and solute and solvent cannot be separated by filter paper. Now can you separate milk particles from milk and fat and all that things that are dissolved in milk? No. It can be separated by chemical methods only. Now, what is the size of particles? Size of particles is smaller than suspensions but greater than solutions. Means it is between suspension particles and solution particle size, that is 1 nm to 100 nm. Now, colloid is a stable mixture and particles do not settle down at the bottom over a period of time. So, if you take a glass of milk and then if you leave it undisturbed for some time, will you see that milk particles have settled down at the bottom? No, they remain suspended throughout the mixture. They do not settle down when left undisturbed, which means colloid is quite stable. Next, some examples of colloids are in the table and this table is very important. So, dispersed phase, dispersed medium, type and example. So, liquid is dispersed phase, dispersing medium is gas and it will form aerosol. Type is called aerosol. Some examples of liquid plus gas are fog, clouds, mist. Solid plus gas will form aerosol, smoke, automobile, exhaust. Gas plus liquid will form foam, shaving cream. Liquid plus liquid, emulsion, milk and face cream. Solid plus liquid, sole, milk of magnesia and mud. Gas and solid will form foam, rubber, sponge, pumice. Liquid plus solid will form gel, jelly, cheese, butter. Solid plus solid is equal to solid, sole. Examples are colored gemstone, milky, glass.